many people nervous. It would turn very, think of it as an alternative. But I think none of us as English as a native language, so it's an opportunity to practice and think of it as such. And you know, now we have the advantages. Now it's an advantage of having such an intimate community. We are amongst ourselves, so again, we'll be very nervous. With one exception of judgment, we should like to go in alphabetical order. So, first, I'd actually like to ask you to talk for 10 minutes, however it suits you. So, thank you.
Hello, who doesn't know me? I'm Nelda. I'm originally from Lithuania, but currently I'm studying my master's in physics of life and health at the University of Amsterdam. And my talk will be about shaping the future of manipulation. And it is based on the paper written by Hisham Dalakia and Thomas Chijmar. It's published in 2011 in Nature Photonics. And it is overviewing the impact and emerging applications of shaped light in the field of optical manipulation. At the beginning of 17th century, Johannes Kepler saw the tail of the comets, and he suggested that it is caused by solar force from the light. In 19th century, Maxwell said that the light is actually the photons. And the photons has a momentum which induces the radiation pressure, and it was experimentally proven, and you can see in the symbol
I have one question about trapping the air bubbles. Is there anything more in the paper about that? I mean, is it actually, did they do that? Is it
No, the
possible?
paper is actually just overviewing all applications, but it doesn't really go deep how it's done.
Okay. So they don't mention they trapped an air bubble because that, I mean, seems really
The
good.
holospheres in general can be gas bubbles or air bubbles, just as an example that it's the lower refractive index, and the gas bubbles can contain the drugs, and you can trap them and deliver to the targeted cells.
Okay. Thank you.
Yes.
Do you know how they use optical tweezers to differentiate stem cells? Based on what?
No, I don't know.
Or how they do it for cancerous and normal cells? Is it single cell by single cell? They analyze each cell, or is it like a flow somehow, like how you showed?
Like this one?
Yeah.
So they differ by size.
By
So we have different intensity, and it will exert different force of the different size of particles. So it's just by size, not actually. In this way, you cannot know if it's cancerous cell or not. Then you need like optical structure, which could actually measure elasticity, which are different for cancer cells and not. But it's different kind of differentiation. This is just by size. Thank you.
We thank you for this excellent talk. With your